Okay, I decided to skip over number 10 and move straight to number 12. And this is on page 293, still working on the central limit theorem, section 6-5. And this is entitled Elevator Safety. Exercise 11 uses mu equal to 182.9 pounds, which is based on data set in Appendix B. Repeat exercise 11 using mu equals 174. I'm not sure what's happening here. Alright, I only got it back. Mu equals 174 pounds, which is assumed mean weight that was commonly used just a few years ago. Alright, the answer to number 11, let's do number 11 since it goes with number 12. Okay, so in 11, example 2 referred to an Ohio elevator with a maximum capacity of 2,500 pounds. When rating elevators, it is common to use a 25% safety factor, so elevators should be able to carry a load that is 25% greater than the state limit. The maximum capacity of 2,500 pounds becomes 3,125 pounds after it is increased by 25%. So 16 male passengers can have a mean weight up to 195.3 pounds. If the elevator is loaded with 16 males, find the probability that is overloaded because they have a mean weight greater than 195.3 pounds. As example 2, assume that the weights of males are normally distributed with a mean of 182.9 pounds and a standard deviation of 3.8. Mean is 182.9, standard deviation is 40.8. And so Alright, so N is 16, we're going to have 16 males, and find the probability that it is over because they have a mean weight greater than, so we want the probability the mean weight is greater than 195.3 pounds. Okay, so here's our 182.9, 193.5.3, and we're looking at that. Okay, so our z-score would be 195.3 minus 182.9 times the square root of 16 over 3.8. So 195.3 minus 182.9 equals times square root of 16 would be 4 equals divided by 40.8 equals, and I get 1.22. Alright, so our chart 1.22 is 0.888. So we want to subtract that number from 1 to get the shaded region to the right. 0.1112. Okay, and what I'm looking at, the elevator is not safe because it looks like that this is likely to happen. That is, that their mean weight is greater than 195.3, which would put the elevator safety in question. Okay, so in 12, they have us change it slightly. Okay, the assumed weight from a few years ago, and we can see that the new weight is quite a bit higher than the old weight. Okay, I'm assuming that's staying the same as is the n equal to 16. So the probability that x bar is greater than 195.3 okay, so z would be 195.3 minus 174 square 16 over 40.8. So 195 minus 0.3 minus 174 equals I'm square 16 is 4 divided by 40.8. I'm getting a 2.09. So for this one, we'll get 0.9817. So we want to take 1 minus 0.9817. So 0.0183. This time the probability is unlikely. So elevator will be safe. So we can see a problem that may be occurring in terms of elevators that were manufactured a number of years ago when this was the assumed mean weight, and now the assumed mean weight is quite a bit larger. We may begin to see problems with elevators that are overloaded in a case like this problem number 11. That is a problem with that one. So we definitely need to be concerned about elevator safety in a case like that. So might not want to get on an overcrowded elevator that's been created and adjusted based on a lower average mean for the population. So something to keep in mind.